Alright, welcome back to part 2 of 3.7 inverse functions. We were just going to look at this triad. So using the table, find and interpret f of 60 and f inverse 60. So noticing that f of 60, the x, or in this case t, is minutes, and f of t is miles. So it looks like distance and time. So time and distance for traveling purposes. So when we have f of 60, f of 60 is 50. And that means after 60 minutes, you've gone 50 miles. All right, so now we're going to do the inverse f of 60. All right, so to do this, basically what we're doing is we're flip-flopping what we're considering the input and the output variables. So at this point, the input variable is now the miles instead of the minutes. So 60, which would be 70. So f inverse of 60 equals 70. So that means you can go 60 miles. So it still stands for miles in 70 minutes. So all we're doing is we are changing what the input is. For the regular function, the input is minutes. And then for the inverse function, the input is miles. Okay. So how to, given the graph of a function, evaluate its inverse at specific points. So again, just think of the inverse, the x's are y's, the y's are x's. So find the desired input on the y-axis instead of on the x-axis of the given graph. And then read the inverse function's output from the x-axis of the given graph. So we are going to, using the graph in the figure, find g inverse of 1 and estimate g inverse of 4. So instead of going here, normally we would, if we were finding g of 1, we'd go over here to 1 and we'd go up and we'd find out what that point is. But instead, we're going to find our input on the y-axis. So you're going to go up to 1 and it looks like it's 3. So g inverse at negative 1 is, at positive 1 is 3. Now, we're going to estimate g inverse at 4. So for this one, we're going to go up to 4 and we're going to go over. And it looks like, right there, that looks like 1, 2, 3, 4, 5.5. So I'm thinking it's 5.5. So here we're given the y's and we're giving the x's because, again, in this case, for the inverse, what would be the y for the regular function is now the x, or the input value for the inverse function. Okay, so now we want to find inverses given a formula or given a function in equation form. So what we're going to do for those is first rewrite f of x as y. That's the first thing you're going to do. So instead of f of x equals, we're going to have y equals. Next, we're going to switch x and y variables. So everywhere we see an x, we're going to replace it with y and vice versa. So our new equation is x equals 2 over y minus 3 plus 4. Okay, so you see what we did? We just switched the y variable and the x variable in the equation. And last, we're going to solve for y. So if I want to solve for y, and y is right here, I'm going to subtract 4 both sides. And on the left, I have x minus 4 equals 2 over y minus 3. Those 4's cancel. So now my problem is that my y is in the denominator, so to move it to the numerator, I'm going to multiply both sides by that denominator. Just get rid of that fraction. And what you do to one side, you have to do to the other. So I'm multiplying both sides by y minus 3. So the y minus 3 on the right cancels, and that leaves y minus 3 times x minus 4 equals 2. Now at this point you might think, oh, let me multiply, but remember the whole thing that I want to do here is I want to get y by itself, so I really need to get rid of this other stuff here. So let's get rid of this x minus 4 by dividing it. And what you do to one side, you do to the other. So the x minus 4's, those cancel. And now I'm left with y minus 3 equals 2 over x minus 4. And now to get rid of one more item, we want to get rid of the minus 3. So I'm going to add 3 to both sides. And my new equation is y equals, because the 3's canceled, 2 over x minus 4 plus 3. So we would write our answer as f inverse of x is equal to 2 over x minus 4 plus 3. And that would be our final answer. Okay, so let's find the inverse of this function, 2 plus the square root of x plus 4. Now, before we do that, let's talk about domain. So I know the domain of f of x is all numbers where x plus 4 is greater than or equal to 0, right? Because I know what's under here has to be positive. And if I were to solve that, I would end up with x is greater than or equal to negative 4. So x is all real numbers from negative 4 to infinity. Now this is the domain for f of x. But that means it's the range for the inverse function, right? So let's find the range of f of x, because if we find the range of f of x, we're really finding the domain of the inverse of x. So for the range is outputs. So what outputs will we get? So let's think of this. If I were to put in the smallest number, which is negative 4, as my input, that gives me the square root of 0, which is 0, so I get 2. If I put in, let's put in another number. I'm going to put in something that's going to give me something nice. I'm going to put in 0. So the square root of 4, 0 plus 4 is 4. Square root of 4 is 2. Oops, I'm writing this wrong. So I said it right, wrote it wrong. So there we go. Okay, so what's happening is our numbers are going up from 2 up to infinity. So our range is from 2, because that's the smallest possible answer you could get, up to infinity. Now, that is our range for our function, but it is the domain. It is the domain for our inverse. So the domain for f of x, and then just write it this way, the domain of the inverse function is from 2 to infinity. So there's going to be some questions where they ask you not only to find the inverse, but also to find the domain of the function and its inverse. So to do that, we find the domain of the function, and then find the range of the function, and the range of the function is the domain of the inverse. Okay, so now we're going to find the inverse function. So I'm going to replace y for the f of x, and then I'm going to switch the y and the x. Oops. So I'm going to subtract 2 on both sides. I get x minus 2 equals square root of y plus 4. And then to undo the square, to undo the square root, I square it. What I do to one side, I do the other. That leaves me with x minus 2 squared equals y plus 4 because the square root canceled. Now I'm going to subtract 4 on both sides. And so that means my inverse function is equal to x minus 2 squared minus 4. That's the inverse function, and this is the domain of the inverse function right there. Alright, so now you guys try this one. What is the inverse of the function f of x equals 2 minus square root x? State the domains of both function and inverse function. Okay, so hopefully you paused the video and you tried this one, and now you're coming back to check out the answer. So before we find the inverse, let's go find the domain of both functions. So basically, to find the domain of the function, I know that what's inside here, inside the root, has to be greater than or equal to 0, and I don't really have to solve anything there, so I can just write the domain of f of x is equal to 0 to infinity, including 0, so bracket. Now, the range of this function is the domain of the inverse. So if I found the range of the function, I'm finding the inverse. If I find the range of the regular function, I'm finding the domain of the inverse. So let's find the range. So what kind of numbers will we get for the outputs here? So let's think about what can we input. So we know we can input numbers from 0 to infinity. So let's just see what kind of numbers we're going to get. If I put in 0, 2 minus the square root of 0 is 2 minus 0, which is 2. If I put in 1, 2 minus the square root of 1 is the same as 2 minus 1, which is 1. I could put in the square root of 2, but it doesn't have a nice square root. Neither does 3. So I'm going to put in 4. 2 minus the square root of 4 is 2 minus 2, and I get 0. The next number that has a nice square root is 9. So I'm going to put that in. And you get negative 1. Now the point is, do you see what's happening? All the numbers are getting lower. So 2 looks like it's the highest number. So all the numbers for your range for this function, it's going to be all numbers that are less than or equal to 2. And that's your y's. Now, in this case, though, we need to think about it as the domain of the inverse, so it would be x's. So in this case, the domain of the inverse is negative infinity, and I should do a parenthesis there, negative infinity to 2. Alright, so, and again, all I did to find the domain for the inverse was I found the range for the inverse, and that makes it the domain. I'm sorry, let me repeat that. All I did to find the domain of the inverse is I found the range of the function, and that becomes the domain of the inverse. Now let's find what the inverse is. So this becomes y equals 2 minus root x. I'm going to flip-flop my x and my y. And I'm going to subtract 2 on both sides, and I get x minus 2 equals negative square root of y. And then I'm going to divide both sides by negative 1 to get rid of that negative. And that gives me negative x plus 2 equals positive square root of y. And then I'm going to square both sides. And you can leave it like this, negative x plus 2 squared. You can multiply it out. You can also rewrite it like this. And that's kind of how the book has it, equals y. So in this case, inverse f, or f inverse of x, is equal to 2 minus x squared. And then, like we said, the domain of that is negative infinity to 2. Alright, so now, finding inverse of a function using the reflection about the identity line. So basically, what you need to know about graphs is really easy to graph an inverse of a function if you already have the graph of the function. Because basically all you do is you find some points on this graph, and then you flip-flop the x's and the y's. And what you'll see is it's a reflection over the identity function. So let me graph the identity function. The identity function is y equals x. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, negative 1, negative 1, negative 2, negative 2, so on and so forth. It's where y equals x. So this is our mirror line right there. This is the line y equals x, or f of x equals x, however you want to write it. Okay, so for the inverse, what you can do is you can figure out a couple of the points that are on the curve over here. So I've got the point 1, 0. I've got the point 2, 1. And this looks like the point 1/2, negative 1. Okay, so for the inverse, all we do is take these same points over here, and then you just flip-flop the x's and the y's. So recopy the whole thing. Just everywhere you see an x, you put the y instead, and vice versa. So you flip them. So 1/2 negative 1 becomes negative 1 1/2. 1, 0 becomes 0, 1, and 2, 1 becomes 1, 2. So now we're going to plot, and I'll do a different color, these points, and it will be the inverse. So we've got the point negative 1 up 1/2. We've got the point 0 up 1, and the point 1 up 2, and there you have it. And if you were to fold, if this were graph paper, you would have folded on this line right here, on this diagonal, then every point on the function's graph would fold over on top of every point of the inverse's graph. That's how inverse graphs work. Alright, so there we have it. We learned to find inverse functions by finding the inverse of the equation. We've looked at the graphs. We've looked at tables. We've looked at just individual points. And that's it. And that's all of Chapter 3. Yay! We're finished. So if you have questions, definitely let me know.